Okay, so let's try and solve the problem of the day in LeetCode. So the problem's title is Matrix Similarity After Cyclic Shifts. Let's read the question. You are given M cross N integer matrix MAT and an integer K. The matrix rows are 0 indexed. The following process happens K times. Even indexed rows 0, 2, 4 and so on are cyclically shifted to the left. Odd indexed rows 1, 3, 5 so on are cyclically shifted to the right. So written true if the final modified matrix after k steps is identical to the original matrix and false otherwise. Okay, so let me just explain the question once again. So the question basically says that you have a matrix, an M cross N matrix, and so in the matrix you have all the rows, right? So out of all the rows, all the even indexed rows, like the even indexed rows as in the first 0 in, let's say this even index is 0, right? So the first row, third row, fifth row and so on, all these are shifted to the left. All these arrays are shifted to the left. And odd indexed rows, which means row indexed 1, which is second row, right? So second row, fourth row, sixth row and so on are all shifted to the right. So you will have this final matrix after doing the same operation for k times, right? And then you have to find if that matrix that for which the operations, all these operations has been done, is it equal to the original matrix or not. Okay, so you have this matrix. So how do we solve it? Okay, they also gave an example for us to understand more, like have a better understanding of. Okay, so there is 1, 2, 3, 4, 5, 6, 7, 8, 9 is the matrix. So how do we represent this in a diagram? This is how we represent it: 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this is shifted, like, and the k is given as 4. So this operation that we've talked about, like shifting the odd rows to the left and even rows to the right, this has to be performed for 4 times. Let's see how it will be turned if it goes through this for 4 times. So the first row has to be shifted to the, because it's an even indexed, it's an even indexed row, it has to be shifted to the right. Okay, it has to be shifted to the left. So it will be 1, 2, 3. When it has been shifted to left, it will be 2, 3, 1. Okay, and the even indexed row is shifted to the left. So the first row is shifted to the left. Fine. And again the third row should also be shifted to the left, which is 7, 8, 9 will be changed to 8, 9 and 7. And then you have the odd index row, which means this one 4, 5, 6, it should be shifted to the right. So it will be 6, 4 and 5. Okay, so this is 1 time, and we'll be doing the same thing for 4 times. So second time, third time, and finally the 4th time. And now after this has been done for the 4 times, we have to just compare if this ending matrix is equal to the initial matrix or not. Okay, so and as we can see, they are not equal, so it'll be false. It'll be false. And then there is example 2 where we have given this time it's a 3 cross 4 matrix and k is equal to 2, so the operation has to be done twice, and let's do it for 2 times. So the first one has to be shifted to the left, so it'll be 2, 1, 2 and 1. Nice. And then the second one has to be shifted to the right, so it'll be anyways 5, 5, 5. And the third one has to be shifted to the left again, so it'll be 3, 6, 3, 6. So this is for once, and then once we shift it to the same thing twice, we'll have this matrix, which is same as the initial matrix. So what do we have now? Yeah, so we find like we've understood how this gets done, right? But so how do we think about the code for this? Okay, so it's just basically simply arraying, like doing the right shift for odd arrays and left shift for even arrays, even indexed arrays, I mean, right? So how do we do the left shift or the right shift in case of arrays? Like how do we do that? Yeah. So basically, for let's just think about this. For for doing a left shift to an array, we just have to move all the numbers to the left, and um, the first one has to be at the end of the array, right? So we'll just store the first one as temp, and then yeah, we will do array of I is equal to array of I plus 1 until I reaches the last one, but until I plus 1 reaches the last element, last index of the array, right? And finally, when it's done, we are going to do the I plus 1 into the element at the last index is going to be the temp object that we've stored, the first element of the array, right? So let's do that. Yeah, so this is for left shift, and let's also think for the right shift as well. So the right shift, you are just going to move all the elements to the right, and you're going to replace the first element of the array with the ending element of the array. That's it. So you are just going to store the last element, right? That's it. Okay, so let's just define functions for both right shift and left shift so that we don't, like, we can just easily do the rest of the process, right? Okay, so we have to do this for all the rows of the array. Okay, so let me just define the right shift first, or left shift, whatever. Left shift, def left shift of an array ARR will be defined as will be defined as yeah, so for left shift we are supposed to move all the elements to the left. While we do this, we should be storing the first element of the array because it shouldn't be gone. And then once we do that, we'll replace the last element of the array with this first element that has been stored. Yeah, so let's do the first element first. Okay, so temp is equal to ARR of 0, right? And then for all the elements in the array, like for I in range of len of ARR, right, minus 1, because you're supposed to, you don't have to do this for the end, until the end, like the last element should be, yeah, substituted with this stored element. So for I in the range of len of ARR minus 1, what you have is ARR of I should be equal to ARR of I plus 1. That's it. And finally, like at the end, ARR of len of ARR minus 1, this element should be given the value of the first element of the array, original array. That's it. This is a left shift. Now similarly, we'll define what right shift would be. Right shift of ARR will be equal to, so this time we have to make get all of them to the right, so it'll be, you are supposed to equate it to I minus 1, and once you're done with all of that, you have to replace the last element of the array with the first element, right? So this time also you're gonna run a loop for I in range of so you have to start it from the second element, so I'm gonna put 1 here instead of 0, which will be default, into len of array, and then yeah, so it'll be ARR of I should be equal to ARR of I minus 1, right? So once you're done with this, you have to replace the first element if it's I is the ending, like if I is len of ARR minus 1, then store it in temp, right? Temp is equal to, so you don't have to calculate length in each step, so which is why we'll just calculate length for once and replace all the length elements here. So let's take the length to be n, and let's just define it here, and this has to be n minus 1. We can also change it here as well. Okay, so last element we've just stored it before it is changed, rotated, we will be storing the temp, and then we will rotate it. So that temp that was stored, the last element of the array, now this value should be given to the first element of the array. That's it, is equal to temp. Great. So this is left shift and right shift defined. So once we're done defining with left shift and right shift, what we can do is we can take a for loop for all the rows of the array. For row in, so this time it's a matrix, right? In mat, for each row you have to apply this for how many times again? For k times. Okay, so once you're done applying, you're also going to return the array, return ARR in these functions. So so you're going to do this for like k times. So for I in range of k, row equal to you have to perform, okay, if you also have to like check whether it's even or odd, right? So let's take index is being equal to 0 first, if the index is even, right? For even indexes you're supposed to do a left shift. So if k times, you're going to do left shift or right shift based on the index. So if index %2 is equal to 0, which means if it's even, you're going to do a left shift. So left shift of row, and else if it's an odd number, then you're going to do a right shift of row. Great. So once you're done with these k things, At any point, if you find that the row that has been changed, if it's not equal to the original row, you can pretty much just break the loop then and there itself, right? So for that, we have to store the original part of that matrix as well, like original row of the matrix. So that's why we can't really change the row itself. Let's say shifted row, maybe shifted row, and then we can do the comparison if that shifted row is equal to the original row or not. But I think in Python we can't really do the array comparisons by just equating them, which is why we're supposed to like compare the elements of it one by one, I guess. So maybe I'm going to do for element in row, or let's just take indexes, for j in range of len of row, if equal true. Okay, this has to be a boolean. If row of j is not equal to row of shifted row of j, then if it's not equal, then just break. Before breaking, also make this equal boolean is equal to false, and then break it. And then if not equal, then just break, right? Yeah, you can just break. Yeah, before you break, you can just written, you can actually just written false. You don't even have to break. So once this whole loop is completed and you show that all the rows after they're shifted are equal to the original ones, you can just written true. That's it. Let's run and see if this code works, or if there's any problem with this. There is a syntax error at line 13. Okay, so if I is equal to n minus 1, there's supposed to be a semicolon. Okay. What's the problem with this? Oh, there has to be an indentation here. Okay, so if not equal, this doesn't really work. Let's just do this. Where is the array used here? Oh, okay. This has to be separately written for both left shift and right shift, because array is the parameter given to those functions and not an absolute value. Shifted row. It's supposed to be shifted row. Okay. Okay, so 2 cases passed, but the first case failed. What's the problem here? Okay, so let's also just print all the rows, right? You know what, whenever, if like, even if a single element is not equal, you can just return false, and then we don't even have to come out of this loop and then like store a variable equal and not do all of this. So let us just return false here itself. And if it successfully completes everything, you'll automatically return true anyways. And yeah, but also before doing this, let us also return like you do this k times, right? Let's just for every row in matrix. So let's print that row once it's shifted. Print row and both row and shifted row. So let's use an f string. So row is row, great, and shifted row is shifted row. Okay, so let's try and run this. So row is 3 to 6 and shifted row is 3 to 3. Okay, so it's not even shifting it. Oh, okay. So remember, in Python we can't really equate two arrays, which is why we can't just do this. So maybe instead of returning something, we could just let the operation run, like instead of doing anything. Okay, so let me just remove this return function so that it just does the operation basically, and you don't have to equate it to get this thing. Yeah, but you'll also have to store the original row before you perform this operation on the row. So let us store the original row. Which is original row is basically you're going to assign an empty array, and then you're going to copy all the elements of that row into this for I in the range of len of row. Sorry, it has to be element, right? Range of len of row. For each element in row, you just have to append it to the original row. That's it. Original row dot append ele. Right. So then after you're done with this, like you don't have to do shifted row equal to, because row itself will be changed, and you will have to show the original row instead of the shifted row, and shifted will be just row, and here you're comparing each element with this row of shifted rows. It should just be original underscore row into, it should be equal to this. I hope this should work. This time the second case failed. I don't know why. Yeah, great. So case 4, case 2, case 3. Okay, what's wrong with this? You can see it's just appending all of them. And why is the shifted row 1 2 2 1? I mean, wait a second. So if k is 2, you just have to do this twice. The first one you have to move it to the left, so it'll be 2 1 2 1, right? So when you're doing the left shift, oh, this has to be equal to temp, not array of 0. I'm sorry. I think now it should be fine. Great, let's submit it. I hope there shouldn't be any time limit exceeded error. Nice. Okay, I think this was I mean, even though it's easy, I think this is it for today. Let's hope to have a better session tomorrow. Thank you.